We're going to look at three examples of how to solve exponential equations. We're going to do all of these. This is an exponential equation because it has a power of x. When you have a power of x, the best way to solve them is using a logarithm. Well, if we go put this into logarithmic form, we should have the log of 0.4, log base 0.4 of 13 equals x. We do that because 0.4 is the base of the exponential, will also be the base of our log. It asks us which power gets you from 0.4 to 13, and that's what x is. So we go ahead and we take our log. Right now that's not going to work, so I need to go my log with a base. Where is it? There we go. My log with a base of 0.4 of 13, and we'll get x equals negative 2.799. It's possible to have x being negative here because that goes ahead and puts you as a negative exponent. It's not giving a negative result for this exponential. We go ahead and next we can look at this one here. So this will be our second problem. When I go look at this, this is a quadratic. We have e to the power of 2x and e to the power of x. If we just had e to the x, it would be a lot easier to solve, but e to the 2x is e to the x squared is e to the 2x. Now, the easier way to solve one like this is to do some substitution with it. And we can call e to the x, say, any other variable. Let's go give it a. Well, we have the number 3. E to the 2x is e to the x squared, or in this case it's a squared, plus a minus 4 equals 0. Well, now this is a quadratic, so we can solve this in a number of ways. We could do quadratic formula. We could go ahead and find difference of, not the difference of squares, the complete the square. That will be very hard in this situation. But the easiest way here is just going to be to factor. So we can go do 3a and a. And then let's see here, we're going to go plus 4 and minus 1. You'll notice 3a times a, 3a squared, 3a times negative 1 is minus 3a, plus 4a gives us a, times 4 times negative 1 is negative 4. Now we can go ahead, we have 3a plus 4 equals 0, or a minus 1 equals 0. Because these are the two values. One of these multiplies by the other to get 0, so one of these two have to be 0 to give us 0 as a result. So remember though that a is e to the x. So when you go solve this and get a equals negative 4/3, you're really saying that you have e to the x being negative 4/3. Well, there's not, e is a positive number, and when you take it to the x power, you can't get a negative out of it. It doesn't matter how many times you multiply it by itself or how many times you divide it by itself, it's just not possible. So let me look back over here where you have a equals 1, which means you have e to the x equals 1. Well, one way for that to happen is for x to be equal to 0. You could have also transformed this into log form. This is log base e of 1 equals x. Log base e is also the natural log. Here you go, look at when you plug it into the calculator. Here's a natural log of 1. Gives you 0 as well. Last one we'll do. Go give you a second to digest this. At this point, if you're looking at this on your computer, I want you to pause and I want you to see if you can figure out how to go from here. This is something that you have not seen anything like before. How we can go ahead and solve this is once again with substitution makes this much easier. E to the power of 2x, sorry, not e to the power, 5 to the power of 2x is easiest replaced as your other variable. We'll call it y. I know we called it a earlier. That makes 5 to the power of 4x y squared. So here you have 3y squared plus 3y plus 2 equals 2y squared minus 3y minus 3. Sorry for all that getting in the way. Well, it's a quadratic again. All you gotta do is get one side equal to 0 and then start solving. So subtract 2y squared on both sides, you have y squared. And then you have add 3y to both sides, so it's plus 6y. Add 3 to both sides gives you plus 5, and the other side's all 0. So you have y plus 5 times y plus 1 equals 0. So you have y equals negative 5 or y equals negative 1. Well, the problem behind that is y is e to the 2x, and it can't equal a negative number. I don't like that I gave that to you, though. It wasn't intended to be that way. We're going to assume instead that this was like a negative 6y for a second. Completely different problem. Because that way you're going to see how this would go ahead and be solved. So if you had it coming out to be, if we made this a negative 6, it would be negative 5, negative 1, would make this 5 and this 1. Well, so you get 5 to the 2x equals 5, and 5 to the 2x equals 1. This would be an easier one to do because, well, this is 5 to the first, and this is 5 to the 0th power. But say it didn't come out like that. Say it came out something harder, like 5 to the 2x equaled 17. You'd go put it in log form again. You'd have log base 5 of 17 equals 2x. This is a number. Divide both sides by 2. I want to remind you that for this problem was actually no solution because you couldn't have either of these to come out to be a negative.